All right, this is a continuation of page 2 of notes 1 of math analysis. We're talking about radians, how to convert from degrees to radians, how to convert from radians to degrees, what are radians, all kinds of things. So radians, a new way of measuring angles. They probably don't feel totally normal to you yet. That will happen over time, but honestly, decimal radians still don't feel all that normal to me. Like I still convert them to degrees to get a sense of what's going on. Some radians, however, are going to become very famous for you. You're going to think about them all the time. So to convert from degrees to radians, so you start with degrees, I don't know, 25 degrees, you're going to convert it to radians. You're going to multiply by pi over 180 degrees, right? So it's pi over 180 degrees gets you from degrees into radians. 180 degrees over pi gets you from radians back to degrees. Now, both of those involve 180, and because we're going to do a lot of problems by hand, it's actually really useful to review the factor pairs that give you 180. So let's make a list of those. So this will be factor pairs. For 100, my hand fell off the side of the iPad. For 180. So not really 180 degrees, just like in general, factor pairs that give us 180. So to get the ball rolling, let's do the useless one. 1 and 180. It's not useful, but whatever. 2 and 90. 3 and 60. 4 and 45. 5 and 36. 6 and 30. It's crazy how many factors there are. 7 does not work. Does 8 work? 8 doesn't work. So I could tell that 8 doesn't work, by the way, because what I tried to do was I tried to double this, and then if I double that, I would have to have this, but 22.5 isn't an integer, so it's not going to be really helpful to us. So I knew that 8 wouldn't work. 9 does work. So 9 will give me 20. 10 obviously works. 10 and 18. 11 doesn't work. 12 does work. 12 and 15. 13 doesn't work. 14 doesn't work. And then we're just at 15 and we're just going like back down. So these are your factor pairs that give you 180. Now, why is that useful? Well, it's kind of useful because we are going to convert these. So if there's a degree sign, it's in degrees. If there's not a degree sign, it's in radians. So here, I mean, basically the second column looks like it's all in radians. So 5 pi over 6, normal radians, got a pi. Pi over 12, normal. 7 pi over 36, normal. Pi, totally normal. 3, really weird. I refer to 3. There's no degree sign. So I'm going to say that 3 is a naked radian. That's not a technical term. Like, I don't think you will find that in the literature anywhere. I think of all radians that don't have pi in their numerator as naked radians. They should have had pi. Like radians want to be in terms of pi. And when they're not, they look weird. And they're what I call naked radians. So let's see if we can convert. So 35 degrees. So what I want to do is multiply by pi over 180. All right, so 35 is 5 times 7, and then pi, and then 1/8, okay. 180, I now know, is 5 times 36. So I'm going to say that this is 7 pi over 36 radians. That's it. You just say radians. You don't write radians. There's no notation for it. It doesn't have a symbol. It's just 7 pi over 36. 35 degrees corresponds to 7 pi over 36 radians. So what we're doing here is we're like the Google Translate working between degrees and radians, right? Like it hears you say 35, it automatically translates it for all the engineers out there, anybody doing stuff with actual math. It translates it from degrees immediately into radians for you. So 7 pi over 36. Now here, I need to multiply by 180 over pi because I want to go from radians back to degrees. So it's useful. I can do 5 pi over 6. So I know that 180 is 6 times 30 over pi. So the pi's are going to cancel. And then also the 6's cancel. So I get 5 times 30 degrees. I get 150 degrees. 5 pi over 6, you'll find out, is famous. The way that eventually we'll do it, think of the initial things that we did, right, on page 1. all year when you're learning, I'm going to constantly refer to stuff that we previously learned. This is a course where you just need to know basically everything that we do. So when you have questions, you need to ask them. When you're not sure about something, you need to take notes that have the questions. We're going to refer back to things all the time. Like this, what you're doing right now, you're going to be 3 years from now, you're still going to be doing this type of thing. And you need to just make it your second language or third or fourth or whatever language you're up to. It needs to become the next language for you. So eventually what we're going to do is we're going to look at this as 5 times pi over 6. And we know pi over 6 is 30 because we already know that 30 degrees always converts to pi over 6. So that's how we'll do it faster later. So let's see here. So I'm going to multiply by pi over 180. This one's easy enough, like, so knock off the zeros because you can divide out 10. And then 4 over 18 is 2 over 9. So I'm going to say this is just 2 pi over 9 radians. And so we're showing work. So I'm going to multiply this by 180 over pi. So I often forget that degree symbol. It should be there. That's how you end up with degrees. So I'm going to say this is pi over 12 times, well, I know that 180 is 12 times 15 over pi. So we end up with just 15 degrees. Another way to think about this is that pi over 12 is pi over 6 divided by 2. And we know pi over 6 is 30 degrees. So 30 degrees divided by 2, 15 degrees. Totally valid. So like we're trying to use the formulas, but eventually we want to kind of like wean ourselves off of those a little bit. I mean, we want to always know them. There's really nothing that simplifies. Knock off the 10s. So we get that here. All right. I mean, so one way to think about this is pi over 36 is 1/3 of pi over 12, which means if pi over 12 is 15, then 1/3 of that is 5, and then 7 will give me 35. That's one way to think about it. Another way is to think I have to multiply by 180 over pi. So 7 pi over 36 times. So I know 36 is 5 times 30. I know 180 is 5 times 36. 5 times 36 over pi. So the pi's are going to cancel. The 36's cancel. We get 5 times 7. We get 35 degrees. Which is exactly what we got when we thought it through, right? We took 1/3 of pi over 12 is the same as 1/3 of 15 degrees, so that's 5 degrees, and then we have to multiply by 7. So we get 7 times 5. All right, 75. So 75, I mean, we're going to multiply by pi over 180 because we're going from degrees to radians, multiply by pi over 180. That's like, slam that into your brain however you need to. Like, it's got to be there. 75, I'm going to say it's 5 times 15. And like you end up doing a lot of things that you haven't thought about in like ages here. So I chose 5 times 15 because I know that 180 is 15 times 12. So I could have said that it's 36 times 5, and that would have been just as good. It doesn't really matter. So cancel those. So I'm going to get 5 pi over 12. Another thing we could have done is somewhere, I feel like we converted pi over 12, right? Pi over 12 is 15 degrees. Once we knew that, I could just multiply that by 5 to get 75 degrees, and then multiply the pi over 12 by 5 to get 5 pi over 12. So it's all working for us. The next one's really interesting to me because it's almost like what it's all based on. I need to convert this, so I'm going to multiply by 180 over pi. But like, that's just 180 degrees. Now, does that make sense to you? Let me ask you this. How many radians are there in a circle? So how many radians, which is probably somewhere in a circle? All right, well, let's think it through, right? So theta is S over R, but a full circle, S is going to be the circumference, which is 2 pi R. So that means if we combine both of these, we get theta is equal to 2 pi. There are 2 pi radians in a circle. That's a big moment for us, which means half of a circle, which is 180 degrees, would just be pi. A quarter of a circle, which is 90 degrees, would be pi, well, 2 pi divided by 4, pi over 2. We can work out a lot of things if we know that there are 2 pi radians in a circle. 360 degrees, 2 pi radians. Think about that a little more. There's 2 pi radians in 360 degrees, pi over 180. It's like pi over 180 is a weird form of 1. It's like saying there's 1 foot in 12 inches, right? It's how you convert between them. And it just shows up. It shows up all over the place. So good job for us, hopefully, if we're noticing these kinds of things. What should we do here? I'm going to do, I don't know. Well, let's do pi over 180. 135 is actually 3 times 45 degrees. And then times pi over 4 times 45 degrees. Cancel those, get 3 pi over 4. Eventually you will memorize this because we also know that pi over 4 is 45 degrees because we converted that. Pi over 4 is 45 degrees, and then we need 3 of those, 3 pi over 4. Here's our naked radian. So naked radians have weird answers. Now, why do they have weird answers? They have weird answers because I need to take this and I need to multiply it by 180 degrees over pi, which gives me 540 degrees divided by pi. Naked radians look so weird when you convert them back to degrees because you end up with pi in the denominator. Like, it's not normal. But it's okay. Like, you don't need to not have pi in the denominator. It's like, how often do you see pi in the denominator? Like, that's pretty weird. All right, so let's see this. Questions. 1 radian is about how many degrees? Well, I'm going to need to, I'm going to need a calculator, but let's say 1 radian, start with 1, and then I'm going to convert to degrees. So to do that, I need to do times 180 degrees divided by pi. You never need to wonder what to do. As long as you know the formulas and you know, like, geometrically what's happening, just like write it down. And even though this feels like a very weird question, like 1 radian is how many degrees? Convert 1 radian into degrees. So this is going to be approximately, let's go to the calculator. So need to switch. Here we go. Okay, so I want to do 180. I do not need to put in degrees. I guess I could put a degree symbol, but I don't need it, and so I'm not going to do it. The pi sign, the pi symbol, it has its own key. So just press pi, and let's do Control Enter. 57.296. So I'm going to write that down. 57.296 degrees. I always remember that it's like a little less than 60, and that's pretty much good enough. So let's see what our next question is. Our next question, Our next question is 1 degree is about how many radians? So 1 degree times pi over 180 degrees is approximately. So, I mean, without doing the calculation, do you notice something about radians? Radians are huge, right? There's only 2 pi radians in a circle. We already worked that out. So this is definitely 2 pi, and we worked it out already, like way up over here. We were like, hey, let's do this problem ahead of time. Right, so how many radians in a circle? We did that. So 2 pi. There's 2 pi, pi is like 3.14. It's like 6.28 radians in a circle. There's basically like 6 in a circle. Degrees, there's 360 degrees in a circle. Radians are enormous, which, like, you would think would have more implications for us, but it really doesn't. Other than you get like smaller, more manageable numbers to work with when you're talking about radians. Let's go back to the calculator and convert this. And then I think we'll call it a day on these notes, or well, on this page rather. So this is going to be, I need to do pi divided by 180. So I can just type pi, and so I do frequently. When I hit enter, it converts it to the symbol. But remember, the symbol is in the pi key over here. So you're going to do that. If you're on a computer, you can type pi, and it'll be pi. So this is 0. Oh gosh, accidentally use a highlighter there. Fortunately, you weren't watching that part, so you don't know my shame. 017. We're gonna go 3 decimal places on all decimal answers in this class unless otherwise stated. So mark that down in your brain. I'm gonna actually handwrite it on the notes when I get back to them. So 3 decimal places unless otherwise stated. So I will do that in what color? I really like this like super bright pink. So 3 decimals unless otherwise stated. So that's just to get it out of the way, right? You're gonna wonder about that. Now you don't need to. We're always going 3 decimals. So look at all the stuff that we did here. We did a lot of converting. We knew our factor pairs. These are all things that you want to kind of like start thinking about. You can make up your own angles and convert them back and forth, whatever. Your calculator can check them for you. So you should definitely do that. I'm going to stop the video here, come back in the next video, and just keep going. So I will see you there.